Hello and welcome. Today we're going to make mashed potatoes and gravy, and we're going to use that as a means to explore starchy foods as a whole and how two particular molecules, amylose and amylopectin, the proportions that they show up in different plants, and how the grains, semicrystalline grains that they're structured into, give rise to different properties that are important for different foods. Um, and so to start off, what I've set aside here is a couple different types of starches and flours, and we'll go ahead and take a look at those. And from there, we'll jump into our dish, which is mashed potatoes and gravy. All right.
So what you can see here are several different starches. There's brown rice flour, buckwheat flour, which is a little bit darker, tapioca starch, and corn flour. And notice how I'm picking them up. And if you look closely, you can see that they all pack together slightly different. This has a lot to do with the crystalline granular structure of starches. So amylose is helical, that is to say it's spiral, and amylopectin is branched. And each plant, this rice included, has slightly different proportions of each of those, and they make a different granule. The rice granule, for instance, is very gritty because it's angular. So what you'll see me doing here is adding a bit of bacon grease to a pan, and I'll start chopping up the potatoes. If you listen, as I chop through the potato, you can hear them sort of crunch. See, starch is a storage molecule. So when a plant makes sugars through photosynthesis, and one of the things it wants to do is to store that food for later. And starches are a great storage molecule for food, or for simple sugars into a more complex sugar, because starches are not water soluble. So they're just a bunch of sugar molecules glued together with a bond in the middle. And different bond, different branching. Also, the thing that separates starches from, say, something like cellulose, wood, is simply the type of bond in the middle when how you stick those sugars together. And as a storage molecule, starch is really great because it forms a crystalline granule. And in varying the amount of amylose and amylopectin and how you put that crystal together, you can have a lot of different properties. And the other thing that's neat about that for the plant, and the reason these tubers, potatoes here, are such handy foods for us, is in being not water soluble. As you can see here, this is just storage material for the plant for storing food. In being not water soluble at regular sort of temperatures, the plant can store a ton of starch and still be a sort of a water-based kind of thing, and not have to worry about that starch flowing away, which it would have to worry about if it was storing it as sugar. And so as you can see, I'm just chopping these the rest of the way up, but it's worthwhile to talk about at this point. Say I were to eat this potato raw. I actually wouldn't do a very good job of digesting this on my own. For us, our digestion of starch, using our digestive enzymes, they have a hard time getting at that granule. And that varies a bit from plant to plant, but in general, it's a tough nut to crack. And actually, my body, or yours would as well, would attack that with the help of digestive enzymes in the sort of lower portions of the intestine, rather than, if we were eating a simple sugar, it would be digested readily. Our digestive enzymes do an okay job, but, and just getting another shot here of the starches while we fill up the water. Now notice we've added water here. And if you add heat, things get very interesting. And you'll see me there sort of putting the water on to boil. What'll happen is with the addition of heat, and this is where cooking comes in, those starches become readily digestible. Sort of this is how processed foods are made, is by sort of changing the digestion of that starch. Okay, so I'm just chopping up some garlic here to make a gravy, and here in a moment you'll see how that works. But in general, what's happening with those potatoes as they cook is those starches are being moved to a form that the digestive enzymes have an easier time with, which means that the more cooked a starch is, or the more processed, the easier it is for your body to digest it, and the more of those sugars you get sort of all at once. And this is actually why processed foods have sort of a bad rap with obesity, with diabetes, with things of that nature, is that as you play with that balance, there's a sweet spot to be hit, and it's easy to go over. But in any case, okay, so you'll see me dropping the garlic in the pan there. What I was going to tell you about the starches is that if I were to eat that potato raw, what would end up happening, and you'll just see me, sort of squashing up the garlic here, but if I were to eat that potato raw, the bulk of that digestion would be done by bacteria in my lower gut. And this is why sort of raw starches, beans, things of that nature produce quite a bit of gas, because byproduct is methane associated with their digestion. And then in order for me to get that, what I would have to do is to end up digesting the bacteria, in the gut, and so you don't get quite as much out of it calorie-wise. Metabolic rules apply here as well, so it's tough to say with it being inside of the human, but something like 90% or so, if you apply the 90-10 rule, in this fact that the bacteria would have to digest it first, and then you would get a crack at it, so you'd be losing 90% of it to sort of their metabolism before you even get to it. So cooking frees up a ton of calories. Now, what you see me doing here is I've just chopped up some mushrooms. I'm going to add sort of a flavor to the gravy. Gravy's really great because you can really see a lot of what's going on with the starches in the cooking process. And it can actually tell you a lot about what's happening. So I'm just showing you here that, in bringing the mushrooms to a sort of a state where things inside them are freely liberated for make a nice flavor for the gravy. Now at this point, all we've got in the pan there, and I'll add a little bit of the mushroom to the potatoes, but all we've got in the pan over there is just the garlic, a bit of bacon grease, and some mushroom. I'm adding pepper. Notice the peppercorns. I've turned the heat down because you really don't need a lot of heat to liberate the starch. And the bulk of what I'm using is corn flour. So all I did is I just threw some flour in there. Now, the reason we use sort of these kinds of flours rather than what you would see more typically in an American household, which would be wheat flour, is actually my significant other Erica is allergic to a particular protein in wheat. So having a food allergy in the house um, has helped us explore some other options. Now I'm just adding milk. And what you'll see here is the starch, as it sort of becomes water soluble, is it'll start to gelatinize. And the degree to which different starches do this is dependent on sort of the granular structure, so what sort of crystal is made, the shape of it, how angular, and the ratio of amylose to amylopectin, so the helical, so the sort of spiral shaped starch, where the sugars are stuck together in spirals, versus how much amylopectin, which is the branched form. Now, both of these are similar to cellulose, but both have very different properties. So as you can see, it's starting to paste up and sort of form a paste. Humans have been working with starch for a really long time. Starch is handy in paper making, so you can go back to like 3500 BCE, and Egyptians were treating papyrus with starch. It's handy in sort of laundry processing, and it's also handy in the kitchen because, well, it's a great food molecule. For plants, it's a ton of their storage material. So if I want to, make a bean or a seed or something like that, I can do that. I can store in a tuber. Now, what I'm letting you know here is that I'm going to go ahead and add these others so they're not wasted. But I'm not adding the rice flour to the gravy. Now the reason being, so I've added buckwheat, and that'll darken it up quite a lot. It's a darker sort of a flour. But the reason I'm not going to add the rice flour is the rice granules, starch granules, are very angular, so it would make for a very gritty gravy. And there are lots of gritty, like if Japanese pastries come to mind, as having a sort of grittier texture, some of them, but that isn't really what I'm going for here. So I'm adding everything except for the rice flour. Now, as you can see, it started to form, something drastically different. Notice there, sort of how it's semi-translucent. What's happening here at a chemical level is simply the solubility is changing and sort of the structure associated with those granules. As they heat, what's going to happen is, and I'm adding the tapioca starch now, which has a much more sort of packed kind of granule to it. But so as I add the heat, the starch granules will swell and they'll become water soluble. So they'll initially take on some of the water, and sort of this is what's going to cause the gravy to swell up a bit, and the texture is going to change drastically. But also, as that texture is changing, and perhaps more importantly, what's happening is it's becoming, and the same thing is happening in the potatoes over here, it's becoming more readily digestible. This is one of the things that sort of cooking with fire did for humanity in enabling civilization, is it freed up a ton of calories, because eating foods raw, you just don't get as much out of them, and that's especially true for starches. And so we went from being a species that probably like if you look at other mammals, gorillas come to mind, and a gorilla vegetarian sort of a diet, spend 12 hours out of the day chewing, just to get the calories in a readily digestible form. Whereas for us, this video will probably end up around 15 minutes or so, and then I've got all these nice, wonderful tasty calories available. So cooking, really changed things by changing the chemistry of what challenge the environment offered in terms of what we've got to eat and what we get out of it. Because I could gather tons of potatoes, but if I can get 90% more out of every potato I get, and that's a rough estimate associated with energy rule. A dietitian could probably give you a better number there. But you see the gains available to civilization from cooking. And what you see here is the structure's changed quite a bit. And when I add, making a gravy, you're really just playing with 3 ingredients. You're playing with the starch, whatever form you've chosen, whether it be flour or something else. The bacon grease sort of prevents it from sticking to the pan. It adds a little bit of flavor. It doesn't have to be bacon grease; could be any sort of oil. And the milk component, which gives you sort of the water. Now notice here, see these bubbles, something's very different happening here than if I just had water by itself. And a lot of what's happening is that starch is getting liberated and becoming soluble. This little masher guy here is really handy and makes this job a ton easier. Now for my part, I don't really, like a lot of folks, and here's how to tell when they're done and when you're ready to start mashing. Now notice I didn't put a lot of water in here, that's why I don't have to drain the water off. And so I get more of the available calories. Waste not, want not. But if you give it a bit of a mash, and you don't have to use too much pressure, but if it mashes right up, you know you've changed it chemically enough to where you're ready to start making mashed potatoes. Throw that back in a bit, but I've turned the heat off because I really don't need it so much anymore, and it really doesn't matter how high you put the heat as long as you've got it boiling. It's not going to get any hotter any faster. But I just start smashing them up, and they smash up much more readily now because that granular structure has changed. As you can see. Now some folks will use like an electric mixer for this, but honestly I like my mashed potatoes a little bit more chunky and less like processed cream. So I put in about as much effort into this as you do cleaning an electric mixer anyway. So, and it's cheaper. As you can see, a little bit of smashing, and I've started to get that kind of classic mashed potato texture. Add a little bit of butter. Makes for flavoring. Now, notice the gravy has sort of gelatinized and turned, into kind of a yucky sort of paste. You can reconstitute a gravy with a little bit of milk. So I'm putting some milk in here, putting some milk back into the gravy, because all you're doing with gravy is you're playing with 3 ingredients. Give that a stir. And now my mashed potatoes are just about ready. I'll probably put them back on the heat in order to finish them off, but I've got this on low. And the gravy mixes right back up. Now, some folks peel their potatoes. I don't, because I'm not a wuss. No, okay. So you get a ton more out of your, with a lot less effort, if you leave the skins on. One, they're tasty. They add some nice texture. But 2, they actually contain a fair amount of nutrition. So that's me. And here you have mashed potatoes and gravy. Oh, one quick note. cleaning your instruments, anything that you work with starch, right away is a ton easier than if you let it dry. And that has to do with that crystalline structure because, well, with enough time, they will go right back to what they were before, and you'll end up with a very, very, very caked on sort of tough structure. And you don't want that on your cooking utensils, so if you just rinse it right away, you will have a much easier time cleaning it than if you let the starch sort of dry back down, let that water go away, because then you end up with, something very difficult to work with based on that sort of chemical properties that we talked about before. So that's why a little bit of proactiveness with your whenever you're cooking with starch will save you a ton. Well, and that's it.